The Fronius iWave 500i is a monster of a machine. It is feature-packed, filled with all of these features. And today we have 2 reps from Fronius in our shop. It's dirty, it's cold, Frank is here. But let's just jump right into the demo.
Hey everybody, Tay here with Lift Art Studios, and we have a special video for you today here at the shop. I'm joined by some very special people. To my left is
Frank Ray from Art Free.
You know and love Frank. We've done a lot of videos together. And on my right are some special guests. Who we have here?
Hi, I'm Tracy Coliani. I'm with Fronius. I'm the partner account manager at Southeast.
And my name is Cinnamon, and I work for Fronius and tech support. I work in our headquarters in Portage, Indiana.
So they traveled a little ways to come see us. Thank y'all. You guys have seen Fronius on the channel before. We had the iWave 235 when we were doing our TIG welder drag race video, which was pretty fun. We did 3 like big time brands and raced them against each other. Not actually raced them, but you get what I'm saying. So if this looks familiar to you, it's probably intentional on the branding side, right? Like you know it's a Fronius machine right up front. This one though is like scaled up a little bit.
Yeah, so we kind of went to the top in a sense. This does everything, and it's lots of power. And
yeah, I had to directly wire it into my 3-phase power box over there.
This is not for every homeowner, but we're talking like production facility, like high production, lots of power.
Mm-hmm.
You're doing heavy material, or you want to do a lot of it. This is it.
And all of it in one machine.
But what this machine is capable of, it'll do, smaller machines will do, with less amps. So it really showcases everything that you can get for free.
Yeah, absolutely. It's a true multi-process machine, and so it can do MIG, TIG, stick. We can do everything, and it
Can I
is...
do my taxes? In an effort not to get buried in the weeds, which is probably very easy with something this intricate, we're about to MIG weld, we were going to attempt to anyway, with what we already had, to MIG weld an aluminum driveway gate together out of some square tubular steel. That's an actual job we're doing here soon. And we knew this was coming, so Hunter prepared like a sample aluminum gate panel. Could we start there and start with aluminum? And then we got some 1/4-inch aluminum over here if we want to really most people see that and go, oh, you're gonna have to preheat. But correct me if I'm wrong, I saw the numbers that this thing's pumping out. I'm like, maybe we don't have to preheat this time on 1/4-inch. Would I be correct?
Let's test it out.
Hell yeah, let's do it. So, we have the great privilege of being able to test drive this thing for a little while. Not only now, but after Cinnamon and Tracy fly home, we get to keep using this thing. And the first thing we're gonna put it to work on is a gate for a driveway that we're building for a customer made from 1/8-inch wall, square aluminum tubing. So this is the first push-pull gun has been in our shop. And we made a little sample panel over here that I'd love to work with you. So real quick, what's a push-pull gun? And then how many ways within that machine do you have that we can MIG weld aluminum? Let's just hit those points, if you don't mind.
Of course. Yeah. So push-pull means that there is one wire feeder that is pushing and there's another wire feeder that is pulling. That's needed for aluminum wire when you have a longer hose pack. So this one's about 25 foot long. We are still able to feed the aluminum through without any issues because of that second wire feeder.
I literally learned that today. Which is, yeah, I literally thought push-pull was this. Like it was just oscillating, like it's pushing and then it's pulling and then it's pushing. This makes a lot more sense. So given the 4043 wire, the 100% argon gas that we've got into the machine, and the 1/8-inch wall aluminum tubing, how many different ways can we weld that using this machine?
So we could just put it into pulse and just weld with it like that. We could also use what we like to call our PMC process, pulse multi-control. And what that adds is extra stabilizers, an arc length stabilizer and a penetration stabilizer, which is great for manually welding because you're not always going to keep your contact tip to work distance consistent.
Cool.
Yep. And then on top of using a pulse process, you could add a synchro pulse, which is a deviation of your wire feed speed. And this creates a rippled look. A lot of people have heard of the, MIG welds that look like TIG welds. That's
Stacking dimes.
Yes,
Yeah.
exactly. That's what we're trying to achieve with this synchro pulse mode.
Cool.
It'd be like if somebody came up to your machine and was turning up and down your knob while you're welding, but it's very controlled through the welder, so you don't have to do that all on your own.
It's funny you'd explain it that way because when I'm TIG welding aluminum, I find myself
Pulsing
doing
with
that
your
with
foot
my
pedal.
foot pedal. Yeah, because of heat, you want to get the pedal going, feed it in, and then chill out for a second while you travel a little bit, and it ends up being really rhythmic. I can't wait to try these. Can we start simple and then add on features as we go?
Absolutely.
Awesome.
Now getting into our parameters, I like to start by adjusting our wire feed speed. So I'm just going to set this to 290 inches per minute. If I didn't know where to set that at, I could come in here to our material thickness selection and set it from there. Now this is based off of an average welding speed of 10 to 15 inches per minute. So if you weld a little bit slower, you're gonna wanna set this a little bit lower. After we have set our wire feed speed, I'm going to check our arc length correction and our pulse correction. These corrections for a nominal value should be set at 0. That's where I would recommend to start. If you're having issues with your weld, such as spatter or lack of penetration or undercut, this is the settings that you would come into and adjust to make those changes based off of what you need to change. And this pictogram is really gonna help you see how that value changes what your weld is going to look like. So I start with the arc length correction. That one's going to make the biggest change. And then I would modify the pulse correction to fine tune.
Is that changing frequency?
Correct.
Oh, okay, cool. All right, so you've got it dialed in. So we are doing pulse.
Yeah, let's just use what is a nominal, like perfect lab conditions value,
That's
and we'll
what we
set
are,
this
perfect
to
lab conditions.
1/8 inch.
Okay.
Let's see how good the machine is at what it thinks is best.
I love it. Time to put your money where your mouth is, Fronius machine. Let's do it.
The idiot-proof machine versus 2 idiots.
Versus 2 idiots. You're obviously comfortable with this, yeah? You've done it a lot. Can we watch you to start with?
Sure.
And then try it ourselves?
Yeah,
Would you like to be under the microscope?
sure. I'm a little shaky from coffee, but we'll make it work. Thank you.
Is this a suitable test? I've just got this piece of extrusion.
Absolutely,
I think
yeah.
it's important to point out or to showcase how small the gun is.
Oh yeah, super lightweight.
Being not only water cooled, but also push pull. Other brands of push pull gun,
I
you
got
got a
this.
great big fat bubble right here where their drive system is.
Yeah, hold
And
all
this-
these. These are good thoughts. Hold it. Frank, hold for camera.
Hold your thoughts. No more thinking.
I'm gonna need a light. That's
Well,
why.
no, so I have it cranked.
Oh, you-
The aperture all the way closed.
I
So
see.
you- And then pull focus and then close aperture.
I see.
I want it to be as dark as possible.
Got it. Yeah, because we were a little, right, where's that here-ish? All right, anyway, before we do that, we're gonna cover this a little bit.
Gotcha.
Are you
Yep.
mobile?
Just go.
I can do it, I got it.
Okay.
I may look like a welder, but I can run this as well. Ready?
Yep.
Frank, you brought up some good points
Yeah,
about a
so
push-pull gun.
The size of this, not only being water cooled, it's not much bigger than a regular air cooled gun, and it's push pull. Other brands of push pull guns I've seen have a great big kind of bubble right here where all the drive components are. And so Fronius has done a great job keeping this small and easy to handle. It's not like a two-handed operation.
I mean, I
And
seriously
there's
have
water flowing through all that.
That's kind
Or
of,
coolant.
that
Yeah.
is wild.
Yeah.
Sorry, I just stepped on you there, but I literally have a Tweco MIG gun over here that's about this size and it's air-cooled and not push-pull.
Right.
Yeah.
Yeah. So, well done, Fronius.
And one thing you didn't even mention, this one has the torch controls, the actual screen on it,
That's insane.
where you can change parameters on the fly even while you're welding. But also you could toggle between jobs with this as well, and you can save up to 5 different easy jobs that you could switch between without having to run around the table to the machine to
Run
change. that.
24 and a half feet back of the machine. and
Yes,
then back.
yes, exactly.
Yeah.
24.7.
Yeah, 24/7, sorry. That's awesome. It's an actual LED screen and buttons, so you can change everything you just did over there on the machine. Well, not everything, but most of the core values you can change here.
Absolutely.
Very cool. I know I just said what you said, but I just wanted to say it so I could understand.
Yeah.
Hear it again. That's so cool. So I've got this just scrap piece of aluminum extrusion. It kind of gives us a little inside corner joint. You want to lay a bead down and let us watch? Also,
Absolutely.
in parallel to this video, we do still have this Apex 3 welding camera system from Melt Tools. So we're going to be able to see up close.
And what I'm gonna do is try to keep a 5/8 inch contact tip to work distance while I'm welding, and also a 5-degree push. I am right-handed, so I'm gonna go from the right side to the left side.
Okay, let's close that down. All right, let her rip.
All right.
Whoa, that is
Really-
so nice.
A little bit hot, and we probably could have also turned up that crater fill for slightly longer.
Okay, it's a little hot. You can change that here, right?
Yes. So I'm just gonna turn it down.
You're changing amperage?
I'm just adjusting the material thickness down.
Oh, I see. Which changes everything.
Yep. So as that part is starting to heat up,
Right.
aluminum heats up really fast. We can see we're losing some of that color.
Yeah.
So what I would do next is probably continue to turn down my main current, but maybe turn up my hot start so that it's a little bit warmer right in the beginning.
Very cool. Can we try?
Absolutely.
Yeah.
Yeah, I'll make those changes at the machine
Okay.
while you guys are testing it out.
Okay, sweet. Let me get this dialed in again. What do you think, Tracy? How we doing?
Pretty awesome. I want to get a close look. I've been looking at the through the monitor, which is really cool.
Isn't this cool?
Yeah, I love this setup.
We're getting darker and darker, so it might be harder to find focus. So.
That's awesome.
Here we go.
Held it right over that.
I sure did. No, I did on purpose. I was like, I'm not gonna stop. Yeah. That was a hot start too.
Awesome.
Yeah. And then the part's starting to heat soak. So I was starting to speed up just to be like, it's getting hot.
Well, the cool thing about that hot start is that also it has a slope attached to it too, so we can just gradually ramp back down to main current. I can
Right.
I can extend that out to a whole 10-second long slope.
Right. So if we were gonna keep welding on this part, you could just increase that slope. So it just calms down progressively all the way through.
Yes.
Very cool. Anybody cold? Here, you can just hold
Oh
on to
my
this.
gosh, thank you.
Yeah. Have you run this?
Yes. Yeah. Lots of fun.
What do you think?
Looks cool, man.
It's definitely hot, obviously, but let's hit this side. Can we turn it down a little more?
Yeah. Go ahead.
All right. Yeah. Right. This whole part, really. Up to this. All right. Let her rip.
That is wild.
Yeah, that's nice looking too.
Straight up dimes.
Straight up dimes, dude.
Nice. Yeah, looking good.
Take those dimes to the bank, man.
You will.
You guys need voice recognition in your next.
Yeah.
And then we're gonna work on the laser beam eye weld,
Yeah.
so you get to do it with your eyeballs.
Yeah, right there.
He weld aluminum and it just sets it for you.
Yeah.
So if it sounds a little bit different, I also turn on that arc length stabilizer. I don't know if it's set good or not.
Okay.
Is that what was on last time?
It was penetration stabilizer on last night,
Oh.
which just feeds your wire feed speed to compensate
cool.
for varying. It changes your wire feed speed to compensate for varying stick out distances.
Right.
But your arc length correction actually induces a short, so we'll see how it goes. It has to be set up right.
Try your worst.
Dude.
Let's go.
What?
That's you trying your worst?
Yeah, you could see me pulling all the way back.
Yeah. This is nuts.
Idiot proof.
Yeah. Idiot certified.
So also imagine being able to use that on a robot when you have like, clamps and fixtures in the way. Now you have this stabilizer. It doesn't matter where your torch angle and stuff is
Right.
at.
I mean, even when you're, like, we just welded that stainless piece. Imagine aluminum and getting in like a tight spot, and you can actually increase your arc length and not really have it affect your weld.
Yeah.
finish. That's wild.
Exactly.
Like on a TIG, you gotta like get a big old gas lens, crank your flow rate up, and stick your tungsten way out. With this, you're just like, hey, I'm about to do something sketchy, and the machine's like, I got you. That's awesome.
Do you guys want to see Synchro pulse?
I do. I don't know what that is yet, but I can't wait to see it.
Another scrap piece.
We got a little more
Oh.
room. All right, ready?
Yep.
The do everything for me mode in 3, 2, 1. I'll take 3. Cool.
So I
Probably
kind
move
of
faster, huh?
could tell that it feels like it was like varying too much, like it was going too high and too low. So I'm gonna just turn that delta, like how much it's varying, down a little bit and
Okay.
see if that's easier.
Sure.
Like stormtroopers. What's going on?
Never seen that guy before.
Yeah.
How did that one actually look?
You up? Yeah, it's okay. It's here. It's sort of like you can see the puddles are pretty tightly stacked, and then I kind of adjusted my travel speed a little bit.
Oh, okay. Let's not.
What does that make you want to change anything?
We want.
No, it looks pretty good.
Right on.
Probably starting to get like the V's from the travel speed actually being too fast. So slow it down a little bit and might be rounder.
Got it. Yeah, because you're sort of dragged. There's too much motion in the puddle, basically.
So if we have to cut down some of the heat so that we can move slower, I can do that.
This is the well.
Yeah, I would say just cut it down just a
Like with
smidge.
these hooks.
That's very cool, though.
Yeah, go ahead.
So that's that robot hanging out.
Try that. Yeah.
And because it's synergic, you're like, you lower the speed, it changes everything else.
Yep. But I did make a change to the actual like delta, so it might already be a little bit colder.
Okay, cool.
We'll see what happens.
Yeah.
Sweet.
That's not the first case of that
Yeah.
that I've
You
seen.
ready?
And we ready.
Dude, that's
Cronus irate.
the eye rave.
I caught myself doing my typical motion at first, and then I was like, oh.
Yeah, do less.
Oh, I'm thinking.
Yeah. I mean, without getting too dramatic, I would be very pleased if my TIG weld looked like that. Oh, that's a good way to think about it. That
That's how I
that
do it.
oxide line on the outside.
Just try and keep that as even all the way through, because I mean, you can still see it when you're down here, you can still see it all the way back here, so I just try and keep that as straight as possible.
So here's the operative question. People, if they're at this point of the video, they're like, how much is it? Where can I get one? We've touched on the fact that this is like cream of the crop, big time, high level production machine. But that being said, it's not exactly unobtainium. So can you give us an idea of sort of where it stacks up in like the marketplace?
So that's going to be production facilities. Somebody who's making maybe not what you just did here.
Like aluminum
with a handrail, but
trailers or
yeah, like heavy production, like people lined up welding, and so this is, I guess, showing that end of things, and comparable equipment in other brands. If we just look at amp range, what it'll do, they're comparably priced, but we've shown today this does all the processes really well. It's not trying to stuff an extra process into an existing machine that's a great MIG, so let's try to make it TIG too, or
Sure.
vice versa. So even though we're talking about this being like a Cadillac level machine, you're not gonna be paying that higher price for it. You're gonna pay the market price for it, but you're getting really great equipment from a great company that's family owned.
And like no compromise. Like that's an expensive machine.
It's expensive, yeah.
Right? But expensive and value are often used interchangeably.
It's huge
and they
value.
shouldn't be.
It's
right?
huge value.
Yeah.
If you look at the value, the expense is very reasonable.
Yeah.
For what you're going to be able to do with that machine.
Yeah.
Not just now, but in the future when you need to upgrade and you can do it with software down.
Yeah.
And this machine is comparable in the market for sure. And it's got lots of little baby brothers and sisters. You know, this is the big like 500i. We also go down the same I wave, you know, into a small compact 230 amperage machine.
Yep, and the faceplate is similar, like not as complex in terms of features, but like it looks the same. But it may be something you can carry with you onto a job site. And you can do really great MIG, very similar to this, smaller package in a maybe even a homeowner budget.
Yeah, there are going to be a lot of differences between those machines,
Yep.
but you can take a look at your local ARC3 shop if you want to learn more.
Yeah.
Nailed it. So
Go to Frank. Go to Frank.
I think something you mentioned earlier too is that like when you get, you know, something from one of the other companies to do that, you know, that you get the water cooled, multi-process, crazy wire feeds, smart auto set stuff, it might be comparably priced, but again, cost versus value, like you're not gonna getting, I mean, we could say this real quick out loud or cut it if we want to later, but like there's only if people watching this video know the other brands. You know, there's Lincoln, Miller, ESAB, HTP, and maybe a few others. Like there's a few that are just out there. These are just people who make welders in the world. And only so many of those companies, plus several that I didn't mention, even on paper offer something this scale,
Like that.
these features, and if they do, it's not as good. And it, like that sounds so stupid and like corporate shilling to say, but like it's not.
Yes.
We've all used really high scale like welders from the other companies, and it's like that's doesn't do that.
Maybe it MIG's great, but it's not really a great TIG welder.
Yeah.
Or maybe it's a really great TIG welder and you're just throwing in this MIG process that is really not real functional.
Right.
For even what we did today.
I mean, the last welder we test drove was like great MIG welder. Yeah, it TIGs, but missing some like really obvious basic features. And you're like, well, what's the thinking behind this? It didn't seem like, it felt like a machine that was designed by marketing teams versus by welders and engineers, people that like care about the features and like what it does, you know? So like, maybe that's what's sticking with me the most about this. It's like, you're a welder, you work for a welding company and understand welding. That's where the design for this is starting. Like, what do welders need? Or what have they never had? What are they wanting?
And we learned that directly from the people who are welding.
Yeah.
You know, as far as like the technology patents we were talking about, we get that information from the people using our equipment. What do they want? And then we build that.
Right.
Yeah, that's the benefit of being family owned, is that we can take our customers' feedback and we can actually do something about it. We're not tied to shareholders or to profit. We're more focused on having a product that actually makes people happy and can do what they need it to.
With that being said, we'll talk off camera about future stuff, maybe other videos. I don't even know how long y'all are in town. But to finish up the on-camera stuff, all right. So I just want to say thank you guys for coming by, for all three of y'all helping bring that machine here, letting us, we're going to keep test driving it. We can't wait to mess with it and use it to do some actual work, which is exciting, instead of just go, that was cool, okay, goodbye. You know, like we can actually like learn it. And then I'm excited to figure out what we end up doing with it, and then like, we're going to learn how to explain it better for you know, in our audience continually, and like, oh, here's what
I
works.
look forward to your future like build videos where you're making something.
Yeah.
There's the Fronius.
Oh yeah.
He's using the Fronius.
Big red robot friend.
Yeah.
But that's it for this video. Thank you guys so much for watching. I know it was very dense, so please use the chapter thing on the bottom if you don't care about the technical stuff and you just want to get to the welding. Use all the navigation tools that we got for you. Check out Fronius. Where can people learn more about Fronius directly?
you.fronius.com.
You guys have YouTube, Instagram presence, any of that?
Absolutely, yeah. Check out some of our YouTube videos. If you just search keyword Fronius, multiple things should pop up.
Right on. And then, of course, Fronius can be purchased through
Arc Free Gases. Any Arc Free Gases location. We have them in stock in Roanoke in most locations.
Yeah, and you can order it online.
And you can order online.
Among many, many other welding things. And then follow us if you're not, like and subscribe to our channel, Lift Arc Studios. If you haven't, if you watch this entire video and you're not subscribed, I find that rather surprising. But if you haven't, just click it. It's free and it helps us out a lot. And if you like what we're doing, please consider supporting the people that help support us. Spread the love. Check it all out. Keep welding. Learn. Stay open.
Okay, well.
Thank you guys, Cinnamon, Tracy. Thank you guys so much.
for
Frank,
having us.
always a pleasure.
Yep.
Hunter, nice work.
Thank you, sir. Good job.
We got a driveway gate to build, so we're gonna head out. Good to see you guys. We'll see you on the next one.
Do you guys like bonus content? Well, guess what? Here's the mother load of it. Well, actually, our time with Tracy and Cinnamon was very limited, and there's a lot going on this machine. I mean, a lot. So, Fronius was nice enough to send out yet another rep. Here's a very extended walkthrough with Troy. I mean, you guys, if you want to watch this part, feel free to, but if not, totally understand it, it's fine too. But I would recommend you watch the whole thing.
This
Hey.
is Troy from Fronius.
Hey, how's it going, guys?
What's your role with Fronius?
So my title is Technical Support Regional. At the end of the day, I'm a field welding applications engineer with Fronius, primarily work out of our Southeast office, covering the Carolinas and Virginias primarily.
Nice.
Yeah, been with the company for 2 years now, and it's pretty cool. Been enjoying it.
Were you a welder before?
Yeah, so I went and got a degree in welding engineering technology from Pennsylvania College of Technology.
Cool.
After that, worked as a welding engineer, helping build submarine missile tubes for a couple of years out of school.
Awesome.
Sick. Worked at a asphalt equipment manufacturing plant for a little bit, and then I've got a friend that works for the company in the Northeast, and he knew I was looking for a job, and he sent me the posting, and here I am.
Cool.
Okay. Well, question then. What was your familiarity with Fronius before working with them?
So before I started the company, it'd probably been about 6 or 7 years before since I'd welded with a Fronius piece of equipment. At the time, Penn College was primarily a Miller and Lincoln school, but they were starting to get into Fronius. So I remember, I think I only ever used a machine like once or twice. I want to say it was like a TPSI model, like very similar to an I-Wave. And all I remember doing was like a 3G or like a 3F, like MIG welding, and thinking, that was pretty sweet. That was like really easy. And then that was it, because I think we only had like one machine, but thanks to my friend that's actually a salesman in the Northeast, he, the account is like, the school was one of his accounts, so he actually has been like selling them a lot more Fronius equipment.
Nice.
So if I went back now, there'd probably be a lot more there. But yeah, after that, I went like 6 or 7 years before I picked one up. So I kind of almost had to start from scratch when I got hired, because I just didn't know any of their processes.
Sure.
So, but
And
yeah.
we had some experience with the 235
Okay.
TIG, which is great. I mean, when it comes to, as far as like deep diving on settings, I'm much more comfortable doing that on TIG welders because you've had to learn it.
Yep.
I've been spoiled by like Miller machines growing up, so like they don't make you think much, even the old ones where it's just 2 dials.
Yeah.
There's a chart and you set this dial to that and that dial to that, and that's all you can change, right?
Yeah.
And so like when it comes to, this is by far and away the most advanced MIG welding machine. I don't want to speak for you, but this is the most advanced one I've ever seen.
Probably the most advanced stick machine as well.
Yeah.
It's definitely the most advanced MIG welding machine I've ever seen.
Yeah.
'Cause I spent 2 days on aluminum, and at the very end of it, within like the last 3 or so hours, I finally got it to where I could lay like a decent beam without having too much spatter. It was
Yeah.
either a really cold start, or it was getting hot, or most of the time it was just spatter, because I mean with aluminum MIG, a lot of times the holdback is the span.
Yeah.
And how nasty it gets. So.
And I know there's so much in here that we can combat that with. I mean, it's really just us two monkeys trying to like, launch a rocket into space.
Yeah, so that's part of the difficulty of your job is selling a rocket to monkeys.
Yeah, I've heard it. I've heard it be called like a spaceship. I've heard it called a Ferrari.
Yeah.
I've heard it be
Ferrari
called a piece of junk before. It really just depends on the day and who I'm dealing with. I just try to, make it known that at the end of the day, it still is a welding machine.
Yeah.
It might have like a little different setup. It might be touchscreen. It might only have one knob instead of 2 or 3 knobs, but everything you need it to do is in there. Like the tricky part is just, navigating it. And that's a big part of my job is like giving training, like doing product demos, things like that, just trying to help out the end user the best that I can and getting them comfortable with the machine.
Well, that's why I'm glad you're here, because I've been hoping to leave this session with like a good foundation.
Yeah, absolutely.
Because we don't want to be fighting the wrong setup for hours when we could have just changed one thing in the beginning and had a whole. So anyway, we have, as I told you off camera, we have a 1/8" aluminum tubing driveway gate we're about to fabricate.
Okay.
So I'd like to explore settings for like 1/8", 6061 aluminum tubing.
Okay.
And then currently we have it loaded with the regular MIG gun and some 045 metal core wire that we're about to use to do some like really thick gauge steel welding a big frame for a concrete slab. So like quarter wall, 3/8 wall steel tubing. Which this thing obviously has the power. I think, correct me if I'm wrong, but I think metal core wire is a really good place to start for that type of weldment, these thick metal pieces.
Yeah.
You could do hard wire, I'm sure, like there's plenty, but do you have any input on, I guess, which one we should use for the project?
I don't have it, like myself, I don't have a ton of experience with metal core. I know an internship that I had, they were making like construction equipment. It was like one of the big construction equipment manufacturers, and they switched from flux core to metal core. I know they were doing a lot of robotics with it, and they just felt that was their thing. You can weld extremely hot with it. Like that was a big plus of flux core, but like the benefit of metal core is you don't have to deal with like chipping off slag.
Right.
So that's been my extent with it, but like I'm not against metal core by any means. Just most of my customers use solid wire, but at the end of the day, like I think metal core is pretty cool too. It just depends on what you're using it for.
Yeah.
It'll work great for what you're attempting to use it.
Cool. Well, let's jump right in,
Yeah, because like I know where to find the setting for like ER70S6, so like, but with this like whatever it's called,
that's
Select 70C. Yeah. Do you have any? I guess we'll start through the workflow.
All right.
Yeah.
The main thing that we'll do is like say if we're on like the first menu here, we'll just be coming to a welding process. You go down to filler material, and you'll hit change material settings. So right now it's listing what you're using right now. So E70T-1C, 045, and then that's like your shield and gas mixture. And then these are the individual properties that you've selected. So right now, like this
E70C, 6MH4, these are different classifications. Carbon steel composite metal cord electrode for gas. Yeah, anyway.
I'll keep it, it's, like I said.
Dude, you think I had it on
I think, DC negative, I'm like, I don't know if I've ever done it with MIG welding. TIG welding terms, you might get more penetration out of it, but that doesn't always mean that's gonna, do what you want it to do. So
what are these other, like, the 1C or GS, I think is
Gas shield.
Gas shield.
Yeah, so that's gonna be like if I'm looking at it like in terms of like a stick rod, one of the numbers is always gonna be like, like what position is it for? Is it like all position and whatnot? I'd have to like honestly Google to see what like the 1C would be for metal core, but a lot of it's just like either characteristics like say chemical composition, or it might even just be again like, hey, this is suitable for all positions, or hey, this is really only meant to be used in like a flat and horizontal position.
I see. Gotcha.
So I have to honestly do quick research on it myself. I know the E71, those are usually like a flux core wire, and then going down through it, you'll just have electro rod like 110, that's like a hard wire, going on up, a bunch of the processes, like chromium nickel, some stainless.
Yeah, I think it's the demo machine.
Yeah, with it being a demo machine, we do have like a lot of the a lot of our options in it. So I'll go back to what you had it set at, right?
Okay.
Then next would be, hey, here's the available filler material size that you have. Now, as you're going through it, it's going to give you like, hey, right now, here's like the available options for you, like process-wise, right? And as you click through these menus, that might stay the same or it might shrink. So if I go to 045, okay, then it goes down to like standard pulse, you know? Now if I go to 052, want the standard, 063.
This is about the right thickness. We're gonna have several joint types. We're gonna have fillet, we're gonna have, you know, where this large radius corner meets the end of another pipe, you have a pretty big crater. I think, correct me if I'm wrong, that was the one we kind of had to tweak the most because of the big gap.
Yep.
It sat in there pretty low.
Okay.
We
So-
changed this setting right here, the dynamic correction.
Okay.
So that when we did weld that, it was more built up and it wasn't laying out flat.
Gotcha, okay.
That's why it's on for right now, because I was practicing on that.
Yeah.
And we only know what that does based on like Pavlovian science. We were like,
No, completely
make a
fine.
change, see difference.
Yep.
But what is actually maybe these last two settings right on their own? Maybe walk us through what those are
So,
doing.
big thing that we get whenever we go to sell the machine is like, okay, when you're in synergic mode, you're not able to adjust your voltage, and that's not entirely true. So how we would achieve that is by arc length correction, because at the end of the day, that's what your voltage is, right?
Okay.
It's your arc length
Yeah.
correction. So, and I love like one of our most recent firmware updates is it'll actually show you when you go to make these adjustments what it's doing.
Yeah.
So you're paying attention to the left, that's your arc length, and then on the right, that's like how like your resulting weld is going to be. Yeah, dynamic. I think you guys nailed it. It just kind of helped like focus the arc a little bit, like give you like maybe like a little bit more build up without adding more, you know, filling material
More
to
heat.
it. Yeah, because at the end of the day, that's what would happen. You know, if you increase wire feed speed, you're going to be adding more heat to it, and then you're dealing with either like fallout, burn through, that type of thing.
So you can kind of see it, I guess. You go to negative, the weld stands higher. So that's the buildup you're talking about, right?
Yeah.
All right. What did we have it at? 4?
Yeah, you had a
-4.
-4.
Okay. And I think we'd already saved that down in here.
And 3, I think.
3. Yeah,
Okay.
so there it is.
All right, good. You guys are using the easy job.
Yeah.
That's great.
So then, yeah, we feel pretty good about this. You want to go back to, can we switch over to the push-pull gun?
Yeah.
And play with aluminum a little bit? That'd be awesome.
Yeah, let me grab another battery.
Yeah, let's do that. Swap over.
Honestly, dude, dynamics is the hardest one for me to do. Because
And that's okay.
I really use it, you know, and that's the only way I can tell people. I'm like, just mess around with it. Most people like it going negative.
Yeah.
More than positive. Like,
Right.
And I just say, I'm like, negative, it's a harder arc. Positive, softer arc. You know, yeah. I think negative is harder, more stable. That's how I
And that's all, like, I wasn't trying to quiz on science.
No, it's
That's
completely,
all I need to know.
no, it's completely fine. All I know is I'm like, yeah, I can see one of the guys at headquarters watching this going, like, what did we spend on this like 2 weeks ago?
Well,
Yeah, but you're taking notes, you're copying notes.
that's what Cinnamon said too. It's just like, I don't work for the I'm not auditing you guys. I'm just trying to learn.
Yeah. No, actually, yeah. I was with Cinnamon a couple weeks ago. Like we were covering it.
Oh, wow, dude.
We were covering it too again. Cause we're like, man, this one's just like sheet grease. Like I don't use it a ton. I'm like, I don't use it a ton either.
Yeah.
And it's more of like you kind of know when you need it.
It's like the feeling thing. And most of welding is that. You know, like you can tell me all day that, you know, what changing the frequency does to the bead profile and ACT. It's just like, sometimes you just find a setting that works and it's not exactly weld start, weld end. That's where we found ourselves a lot.
Yeah, exactly. So starting current, okay. Starting, yeah, you can have starting arc length correction. Main thing is with like starting current, ending current, or aka like crater fill, you'll have the timers with it.
We were
If
right.
those timers,
Current is the crater fill.
exactly.
Yeah.
If you don't have a timer set with that, they're not going to be active.
Got
So
it.
if that's 0, you won't have them. So that's like the easiest thing to remember, right? If they're 0, it doesn't matter what's up there, it's going to be down there. You know, you got to make sure that's like ahead of time to it. The slope, all that is like a transition time. So that's just going to be from like, hey, how long do you want to last between your starting current down to your main, and then your main current down to your crater fill.
Right.
Current. That's all. Ending current 40%, ending arc length, and yeah, you can have like starting arc length correction, ending arc length correction, and then end current time. So like you have that turned off, so you won't have anything
Any crater fill?
I'll keep that surprise.
Just because we were welding with the tags.
Yeah, and it's completely
Welding
fine.
with a tag, and it's gonna build up.
Yeah.
Well, but yeah, that looks fine to begin with. And yeah, since you guys are in two-step mode or special two-step, it's all going to be like when you pull the trigger, you're going to activate that hot start time. So it's going to be, I think I saw it was like for like 0.2 seconds, and then it's going to hit your slope for 0.4 seconds, and then it'll be your main welding current. And then say if you guys are going to utilize a crater fill, you have a timer turned off, so there's no crater fill. When you would let off the trigger, that's when it's going to activate the slope 2 to slope down to your crater fill, and then it's going to keep welding. So some people in the beginning, if they don't realize that they have that turned on, they'll stop welding, they like let off, they flip their hood up, and they blind themselves,
Yeah,
right? And then
for
they're mad
sure.
at us, and they're like,
Yeah,
sorry that
for sure.
we didn't tell you, or someone didn't tell you about that. But yeah. So no, I mean, you guys have it going right. Like 165, that's a little hot, but try it, right? I mean,
for stick out, we're a lot more stick out than.
so stick out, I think like our general rule of thumb is like 15 mils. So that's about like 5/8 stick out. Like with aluminum, 5/8 to 3/4. Like if it was a push only gun, I'd say yes. Like doing it yesterday with some customers, like they were messing around going from like 3/4 of an inch to a 1/2 inch, and they immediately saw like, oh wow, that's like a big difference. And like you want to keep it at the 3/4 inch, right?
Yeah.
A push pull gun, like you'll have a little bit more leeway, but yeah, I would still recommend keeping like a longer stick out with it.
Yeah. Okay. Well, let's play with it. See if we can adjust things in real time. Okay. It's low profile tax. This soot, would you clean the soot off, or should it really matter?
If you can clean it, like it wouldn't, again, like cleaning's never gonna hurt, right? As long as you're not accidentally contaminating it, cleaning's never gonna hurt.
Got it. Let's stick with worst case scenario.
Take that other.
Sure.
I stared right.
Awesome. You recommend push, right, with this kind of thing?
Yep. Okay, because we had Synchro pulse turned on, that's what was going like that high and low. And you guys have it set to about like 5 hertz for the frequency. That's decent. You know, I usually start people out with around like 3, you know, whether it's like 2.5 to 3.5. The main thing is just, like the higher the frequency, basically the faster you gotta move with it. So some people love it, like they love cranking it up and just burning with it. Some people it's like, hey, it might be a little bit too much, like turn it down. So that's like the main thing when using Synchro pulse. It's just figuring out what frequency works with your travel speed. It's like the wire feed speed, you gotta figure that out, and then Synchro pulse is like just another step on top of it.
Okay. Give me 3 for a minute. I wanna try it.
Delta wire feed. So since we're switching between at the high wire feed speed and a low wire feed speed, that is gonna be, like that delta is gonna be what's either added on for your high or then subtracted to be your low. So when we had it set to 100 and your main welding speed was 200. So for the high, it's going to be 300. For the low, it's going to be 100, right? 80 is decent, right? Like I think for me, I keep it between like 75 and 100. You know, last thing is the duty cycle is just how much are you going to spend on the high side versus the low side, right?
Yeah.
So,
and that changes the weld. I mean, that's kind of heat input.
Yep. Yeah, and I keep it at 50 to start off. Right, and you might find out that you need to go higher. You might find out that you need to keep it at like 35 or 40. So it's going to be more on the lower side.
Yeah. All right. Well, let's fill this joint the rest of the way out and see what we.
It's a little proud.
Yeah, I mean, it started on the tack there, but that's how you got to do it.
And I know when you're doing the same thing, when you're in Synchro pulse and you're utilizing a hot start, and I'm pretty positive like the crater fill or end current, it won't be with Synchro pulse on. So like we would mess around with it. Say if like we turned your hot start time to like a second, you would just hear like a normal pulse for that second, and then it'll switch over to Synchro pulse. So that's just something to keep in mind too, like that it's going to be your just main in this case like your starting current first, like no Synchro pulse turned on.
Kind of just watching the plug, trying to get it to come along with you. You know, it doesn't want to. Seems a little reluctant to travel, but that was better because I pulled the gun away.
What'd you do there that was different?
I pulled the gun further away, and that was a much better result.
Yep. And that's something that takes a little getting used to, I know, for guys.
Yeah.
Like, I thought it was a little wild, too. I'm like, man, it's a 3/4.
I mean, it's 15 years.
Yeah,
of
like
just
stick it.
going
Yeah, I know,
straight
and you
into
feel
it.
like you're just welding out here with it. But
Yeah.
like aluminum, like it's not so bad on like say carbon steel, but aluminum just for whatever reason it just likes that longer stick out. You
Yeah.
know, like whenever I'm here like doing like burn backs or whatever, I look, I'm like, well, you guys are using like a 1/4 of an inch stick out. Like it's not gonna wanna, it's gonna wanna burn back.
Yeah, and this is old dirty stuff, so that's a pretty good one.
Exactly. You know, and that's what I'm saying. It's like I'd love to, in a perfect world, I'd always say like, yeah, I'd love for everyone to clean their joints and whatnot, but I understand like production environments, they're not cleaning their stuff.
Yeah. I mean, that's not a bad result. Do you have any input based on what you're looking at?
With it being small, it's hard. Like if you were worried about it like being a cold weld, the only thing I would say is like you just like turn up the timer for your hot start time. But I mean, other than that, I mean, I think it's.
I mean, here it's sitting a little proud, you know, so is there any minor tweak we could do to get her to wet in a little bit? So
You could turn up the, so like right now you have like a +5 for the arc length correction for high, but our low is at 0, so 2.5, right?
Okay.
And then just kind of see that with it, to see if that like does anything better for you.
Yeah. Just want to see the difference. Yeah, we'll give her best.
So that would mean when you're flipping back and forth between high wire feed speed and low wire feed speed. So when you drop to like lower, that's going to be the arc length for that lower side. When you had it high, that was going to be the arc length correction for like the high wire feed.
Oh, I see. So when it's not on, when it's off per se,
Yeah.
now we're changing the characteristics of that.
Yep, going just
sort of
between like high, low, high, low. So
Yeah.
yep.
And this is your in-between puddles setting, kind of basically, with your deposits.
Yes.
Yeah.
Yep.
That's not bad.
Stacking some dimes.
Yeah. Bit of a weird start there, but. Yeah, that one, like, when I pulled out, it wasn't. It wanted me to be closer in now. Did you see that?
Yeah, a little bit.
Like I'm about, whatever that is, 3/4 out. See how it slowly starts to melt up towards the torch? I mean, it worked fine.
Profile looked good.
It does look good.
That's what I was. I saw that.
And same thing too, we can, if you feel like you're kind of long arcing it in the beginning, we can mess with the starting arc length correction. So like we could go negative with it. Like if you feel like it's kind of like too long, drop it to like -2.5 in the beginning, so it's like a little bit closer up.
Right.
But then you're just kind of worried about if your start is going to be looking a little bit too big of a beat. That's all.
Yeah.
Yeah.
We're starting on a tack usually.
Yeah.
So.
Yep. Really, the only other thing there is, and it's like it's a type, right? So the other thing would be feathering the tack out, right? But I mean, you don't have a whole lot of room to work with anyway, and I know that adds time to it. Right?
Well, and I know we're splitting hairs. I just want to I want to get in the weeds now and learn as much now so that we can.
No, absolutely. We can try ripple, like the ripple drives, because I'm curious myself to see what that does. Like I'll turn off.
Let's get weird.
Dude, I'm all about getting weird.
What was the original job say?
2.
You want me to save over that?
Yeah.
No? Okay.
Yeah. Not a whole lot's been changed. So you can just click and hold. It'd be nice.
Yeah, that's how you do it. So
Tag that thing.
Hold on, let's change.
Where are we?
Okay, so
I'm gonna go for.
it's rain out sequence.
Yep, exactly. That was gonna be the thing. So I'm curious to see what it does. Does it might help you? Might help.
Do you now? It's on 0.09 inches. Should we change some of this?
Yeah. So I'm gonna go.
Baseline?
Yeah. So that's just gonna be keep it baseline. Right?
We are making a monstrosity. So this is their simulated TIG.
Okay. So alright, now I think I get it. That
Is need a regular gun?
No, I think it might need it might be a CMT process.
Oh, is this where you have the TIG torch and then a wire feeder around the
No,
side?
I think it's actually would be like a CMT process.
Cold metal transfer.
Yeah, and it might be mixed. So I'm gonna try with mixed drive. It might be the same.
Yeah.
Okay. All right. So yeah, they're gonna have to be for.
Okay.
I get that. Okay. All right. Yeah. Cause okay, CMT mixed drive. Okay. See, if you're in CMT, it would be called CMT mix, where basically you're mixing in a hot PMC with like that cold metal transfer, and I think that's just what it was. But in this case, your primary was PMC, and they're just saying, yeah, you're adding in CMT with it. So
got it.
that's a bummer. I learned something today too.
Okay.
I
Well,
should have
good.
known this, but
So we can just jump back to our
yeah.
preset.
Here.
We'll try the dynamic.
I'll let you guys try dynamic just to see if you guys see any difference with it. Yeah, I got that turned on.
So this all the settings are the same as our standard.
Yep, it's just
dynamic.
Yeah, it's just gonna be a little bit more potentially like hot.
Okay. Whoa. I kind of like that. The puddle travels a lot easier. That's cool. Yeah, I mean it's so hot that its burn back is pretty intense.
Oh, yeah.
Like I'm actually losing sight of the wire.
I got you. Here, I'll let me drop down the. Here, I'm gonna decrease arc length correction.
I mean, what it did look good. I started losing the ability to move the puddle.
Here, yeah, try that, and then I might have to do better.
It's pretty good. Yeah, I mean that last little inch there we did, looking pretty all right. Yeah, hit it. Get a hit of that.
Hit that bang.
Hit that bang. I mean, that's pretty.
I like that a lot.
That's pretty hard.
I like that a lot, man.
Hunter!
Wow.
Pretty
good.
I mean, if I did that with a TIG torch, I'd feel really good. You know, like that's saying a lot.
If I was able to strike an arc on aluminum with a TIG torch, I'd feel pretty
Yeah.
good. I need to brush up.
I was going to say, Hunter's got to start like a Instagram for showing off.
Do you want to rip?
I'll take
Get a rip.
Take a hit.
Take a rip.
Take a hit of the good stuff.
Can't come all this way and not take a rip.
You know what's crazy, Tay, is that you can actually see the amperage
The high and low flux.
on the screen.
Yeah.
So
The numbers go up and down.
Yeah.
Like later, if you just have strap piece, I'll mess around with the penetration stabilizer. And all that's doing is basically, it's trying to make sure that you're not gonna blow through material, right?
Yeah.
So if it senses that you're long arcing it, which normally that's gonna like actually decrease your amperage actually going into the joint, it's gonna add more filler material. It's gonna increase your wire feed speed because it's sensing, hey, wait a minute, you're cold.
Which is actually exactly what you do with TIG. Like if you're about to burn through, it's like you need to add like crazy.
Or vice versa. If it feels like you're, well in this case, it feels like if you're about to burn through, it's gonna go, or hey, like you would shorten your stick out, and it's thinking that you're gonna be overheating it, it's gonna decrease your wire feed speed. So when I was learning it, like me and like one of my coworkers, we got hired a couple weeks apart, we were training together. One of us was just sitting there just doing this, like pulling it out, and the other one was watching it just go dropping like that. That's pretty cool.
Cool. Get a rip, dude.
Damn.
Yeah, man.
Shoot, yeah.
I retire.
Yeah. And then we could do a little crater fill if we wanted to address that.
Oh,
Man, that's
my
good.
welding instructor would be yelling at me. So you're too high up on that one, and Ryan, good, you'd be right.
So you can't retire just yet?
No, I can't retire this way. That's why I always say there's a reason why I'm doing what I'm doing. You guys are doing what you're doing. You're way better at doing that than I am.
That's awesome. Well, the whole point of this machine is that it'll fill in your gaps, you know? Like, makes you look like a superhero.
That's what we try to say. It'll make an average welder look good, or it'll look Troy look like he knows what he's doing some days. But I think it's like I said, like once I turn on Synchro Pulse, like I just don't even want to go back.
Why would you? That's the whole
exactly.
point.
And it would be now if you're welding some like really thick aluminum. The customer I was with yesterday, I'm like, hey, you probably don't need it, right?
Yeah.
Because they're welding like anything from 1/4 of an inch up to a 1/2 inch aluminum. I'm like, you guys can probably just keep it in
You're just trying to
pulse,
throw
or even
heat in
just
there,
or even just spray. You know,
Yeah.
I got it. Like they were able to make it look decent with that. But when you're, you know, they were doing like some railings and whatnot. I'm like, it's Synchro pulse. I'm like, it's just
Yeah.
gonna make your day that much easier because, you know, I tell people, I'm like, trying to weld with aluminum, like MIG welding, sometimes like trying to like weld with a hot glue gun, like it just, you know what I mean? Like it doesn't really want to flow with it.
Well, a lot of what we do is more on the cosmetic side versus the structural side.
Yep.
We do a lot of architectural stuff, art stuff, sculptural things. So like we're looking more for
And
the
that's
aesthetic.
and
of
then,
the
yeah,
weld.
and that's where Synchro Pulse is great at it,
Yeah.
you know, because like my only thing I tell people, I'm like, you know, you just got to make sure like, hey, like you are changing the heat input with it, you know, you're trying to limit distortion. So, you know, if you have to run
Distortion's a big
PQR,
one.
yeah, so I'm like, you know, you might have to run a new PQR or whatever because you just got to make sure that, hey, you're gonna like, you know, bend tests are gonna be fine and things like that. But for me, I'm like, you can still like check your overall heat input and you should be fine.
Yeah.
So what was the thing that you changed again in order to get
Hold on a
this?
second. How you doing?
What he changed.
Yes. What did you?
So we
what-
changed. So we wanted to change the individual synergic line characteristic. When we went back to say welding process, I mean, that was fine. That was fine. We came to this menu, and sometimes, like depending on what 3 variables you selected, it might give you more options within that welding process to choose from. So what I did was I went from PMC Universal, and I haven't messed with these other 2 options, like they might have given you better results, but I switched it over to dynamic, right? And when I hit store, when I came back up here, and this is kind of like giving you those individual synergic characteristics, went to information, and it was just saying the difference. So universal was characteristic to cover a wide range of applications, you know, hence universal. But dynamic, it's meant for like deep penetration for high travel speeds. So when we changed that, I think what it actually did was it just basically, I think probably slightly increased wire feed speed, like internally, allowed you to weld hotter, which meant that like you had to move faster with it. And based on like our travel speeds, it actually wound up being pretty good for us. And
Hotter ended up maybe giving us a better
like
bead
just a little
profile.
bit.
Yeah.
with deep penetration.
Deep
It's
penetration.
I mean, aluminum is an amazing heat sink. Like,
Oh, yeah.
I mean, when I'm welding aluminum with my 251 machine back there, I have it turned all the way to the moon, and I'm using a foot pedal. And when it's a cold piece, especially if it's your first weld and there's no heat soak, that pedal is on the ground, and I'm just getting that pedal established. And then some guy told me, he said, you got to stay ahead of the heat. It was a cool way to hear it explained. Like, you got to get that pedal established and start moving to stay ahead of that heat soak, ahead of that, like, because otherwise, aluminum's notorious for having like a cold beginning of the bead and a really hot, wet, you know, saturated end of the bead. And we're trying to get that
And
uniform.
and cracking.
Yeah.
And the crack. I think when I was learning aluminum TIG, I kept sticking like my tungsten in the puddle because, you know, I learned that aluminum has like I guess higher surface tension than steel, so it just wants to suck up into it. So I finally got my instructor, and I'm like, Mike, I'm not getting it. I just remember him like in my ear going, you gotta pull back, man. And I just felt like I'm like welding all the way out here, you know, just because like it just wanted to suck up into that tungsten.
Right.
You know, but yeah, aluminum, like you said, it's like, it takes a little bit to get to melt, but I mean, once it melts, it just wants to go. Exactly, you just gotta move with it.
Yeah.
You know, just doesn't, like, I just tell people, I'm like, steel, you hit it with a torch, it's gonna get cherry red. I'm like, aluminum doesn't because it just dissipates.
It just
the heat.
turns the liquid and disappears in a
has
split second.
has a higher thermal conductivity to it. Like you don't see it turn cherry red.
Right.
Yeah, it just turns to mercury.
Pretty much. Yeah. It's just, and I'm a liquid.
Yeah.
So that was all dynamic, and you had to pre-select that.
So actually, like once I had it selected on universal in the beginning, and
you
then
could
all
still
I did
pick
was all I did was come up here, and I went from universal to dynamic.
So did changing it in the root menu change anything else?
So
Like when you were doing the material selection, is that when you changed it there?
nah, it didn't.
Okay.
Nah, it didn't do anything else. I
gotcha.
think if I went to
But if you were using that menu path as your starting point, that's how you would choose the other one.
yeah, actually, I'm looking to see what the differences are. Like
I only
10,
see different numbers
and then
here.
if I went to-
Yeah.
It actually dropped. Yeah, it actually like dropped a little bit, which actually might actually make sense. That's why you're able to like
That's why it's a smaller
Yeah.
sort of thing.
but
And
still
yet,
gives you what it still gives you what you're looking for.
great. Dynamic it is.
Dynamic it is.
The monkeys have a theory.
Can I do the last one?
Absolutely.
And then we'll save it. That way we
Yeah. Do it.
I mean, that's crazy, man.
Hey.
That is so nuts.
Oh yeah, that's way better than mine.
No, it's not. It's the same weld.
You had it more evenly spaced between
I mean,
them.
you got, well, whatever.
Well, and what can throw people off at first with Synchro pulse is like, I try to say, I'm like, before they weld, if they've never done it, I'm like, just maintain whatever travel speed you think you would normally. Because in that, like, that change, like, it can throw you off. It can make you pause when you don't need to pause. So that's like the beginning of it. Like, just knowing, like, how fast you need to go so that you're not backing up on the puddle, on the puddle and getting that spatter.
Well, this thing's also like a metronome. Like, you know, you set that pulse frequency, and that's the rhythm that I'm following. You know, I'm making sure that when it's hot, I'm sort of stationary, and then I'm moving in between. Even though it's a smooth thing, you're just looking at the spacing between the puddles.
Yeah, and that's
going to be really good for us, I think.
I think
that's really good.
Dynamic it is.
Yeah, save, please. Save your work. Control S.
Yeah.
Cool.
I had a teacher who always said, he's like, if you do something you like, save it.
Yeah. Dude, that's awesome. How do you feel?
Feel good.
Feel more confident?
Honestly, feels good that we weren't really that far off.
No, not at all. No, you guys already had it, you know, and I figured you had to because Cinnamon was here just like a couple of weeks ago.
Not even.
So I'm like, all right, they already know what they're doing. You know, you guys already have a good base of it. Like, you guys had already messed around with dynamics. So I'm like, all right, they definitely know what they're doing. You know, that's more than, a lot of times I show up and it's like, nah, I'm in manual mode. I'm just adjusting wire feed, speed, and voltage independently from each other. And you guys are like, nah, I've got dynamic turned down. It actually worked great. Probably know more about it.
I just don't really know what it does. Yeah.
Well, we figured. I mean, there's all the settings. Like going to full manual seems like almost a complete waste of time. Like, why would you get something with all these features if you're just gonna be too knobbing it? You know.
I look at it as some days I'll get frustrated and I'll think the same thing, and then other days I look at it as like, you know what? If that's what it takes to get Fronius in the shop and just bring more awareness to the brand and our product, is them starting off in manual, I'm cool with it. And yesterday's customer was that. Like, they were in manual and like they had it. Like he was figuring it out and whatnot. And it sometimes it's just bringing in like another someone like me to come in and just going over it one more time for like that light bulb to go on. And he was that guy. Like, he was taking notes all the time. And what I always say is, I'm like, look, I'll set it up the exact same in manual and then in like standard synergy. And I'm like, it's gonna weld that much better. And that's what I did yesterday. And I didn't change anything. I showed him that, and he's like, dang, that was. I'm like, he just wants to react like that much smoother, you know. And I'm like, it just kind of takes the initial thought out of it. But I get it. Like a lot of welders don't like change. I get it too, you know. And I'm like, hey, you spent years like gaining that experience and knowledge to know like, hey, my wire feed speed is X. That means my voltage is Y. Like, I don't need a machine telling me that, you know. And it's like getting it in their head that, look, like, you can still adjust your arc length. Like, you can still do it. Like, it's just, instead of us calling it voltage or trim if you're pulsing, we just call it arc length correction. Yeah, it's doing the same thing.
I mean, the first 10 years I welded, I didn't understand anything. I would pull the chart down, look at the material thickness and go, okay, this is my wire feed, this is my voltage, and close the chart, and then weld. So I never thought, most people, I mean, our friend Steve worked in the shipyard building submarines in Mississippi and then Norfolk.
Okay, yeah.
You know, they have these crazy, DC TIG power units that are just somewhere else.
Yeah.
And so you're running hundreds of feet of cable down somewhere. But those guys are so stuck in their ways. Like, he was like a curious-minded, son of an engineer. He was asking these guys, like, well, why do you set it like this? Why is it? And they were just like,
because it works.
Just shut up. This is what we do it. It's a lot of that in welding is like, we do it this way because we do it this way. And no one's like thinking or trying to learn. My first foray in this was when I bought my first TIG welder. I was like, oh, I have to learn now what is happening at the like metallurgical level, because otherwise I'm not going to know what to do with any of these knobs or any of these settings. So luckily that was another 10 years ago. So now this wasn't as big of a hammer blow to the face as it might have been to someone who's never taken the leap into like the arc profile and metallurgy and polarity changing and all that stuff.
Yeah, I mean, when I was in school, I wish I would have done more of messing around, but it's like you're just trying to like get the technique down, get this and that. That I didn't, I wasn't focused on messing around with it. And then after I graduated, like I was an engineer for like the first like 4 or 5 years, whatever it was. So I wasn't doing a whole lot of hands-on other than, I qualified a orbital TIG welder for like pipe welding, right? But other than that, like I was more like codes and like PQRs, WPSs, dotting your I's, crossing your T's. So when I got this job, that was like my first time actually having to go like revert back to it, and like it's definitely made me better, made me more like think more on the fly, on my feet, like actually having to like do things and mess with stuff. Like a lot of times, like if I don't know something and I'm at like a customer, I'll be like, all right, we're gonna use it as a training lesson right now, and that way like we can both see it. It's like, I might spin it as in like I'm teaching them, but in reality I'm like, I'm actually teaching myself.
And you can see here that didn't work.
Yeah,
so.
I'm sitting there, I'm like, okay, I actually fooled you. I was being wrong.
This was a trick question.
Question.
And you failed.
I'm making notes. I'm like, how did that work?
Well, man, thank you so much for coming out here.
You guys are awesome, man. Really. Yeah.
Troy,
appreciate
pleasure.
You guys. Yeah. Like I said, I was in the area. Glad to stop in and help out. You guys gave me something to do on Thursday.
Do you have anything to say to the people about Fronius? This time is yours. Anything where they can go, how they can learn it, resources around them. Obviously our favorite resource is ARC3.
Yep. ARC3 is like a great partner for us. Like I work with them on a daily basis, or at least on a weekly basis. You can go to them. They're starting to love our equipment more. Like we're starting to provide them more training too, so that they're adequate and they don't always have to reach out to us. Like US wise, we have 5 different regions. We have Northeast, Southeast, Central, Southwest, and Northwest. Like here in Virginia, like your closest region would be the Southeast. Our office is based out of Chattanooga, Tennessee. We have, in my region alone, we have like 6 field engineers that do what I do, and then we also have like a handful of field sales reps too. But go to your local distributor, like hit us up on our webpage. I know we're on Instagram. Influencers on YouTube, like Left Dark Studios. We've got like TikTok that are trying to promote our brand. So good. Thanks for having me, guys.
I mean, and ARC3 doesn't just do demos for people like me. They'll do demos for anyone.
Oh yeah, absolutely.
Well, that's a big one. Follow-up question. So you're talking about visiting a lot of customer shops, and like what's Fronius's deal with that? Is that like it comes with a machine? Like if you have troubleshooting, then you'll come.
Yeah. So a lot of times, like if you're going through a distributor, right? A lot of times, like some of our distributors and like some of their field sales or outside sales rep, like they know the machine like forward and backwards, right? So they'll go and do a demo with you, and then say if you buy the machine, they'll come out and give you what we call start assistance. Or for us, like we'll do the same thing, right? If you buy it direct from us, like someone like myself or a coworker, we'll go out and we'll help you like set up the equipment, like do some training. We'll also provide more like actual like classroom training. Sometimes they've had the equipment for 5 years, but turnover happens and some of the knowledge just kind of disappears. So I'll go in and I cater it to what the customer wants. Whether that's like just one day on the shop floor or like 3 days where it's like mixed in like classroom. They want to know the nitty gritty of one of our processes, and then we go out and just mess around with that in the lab.
All right, well, we're gonna prep for these jobs that you've thankfully helped us prepare for.
Yeah, we've trapped you in that. You laid some beads on a thing that we're gonna sell.
Yeah, and here it is, our Precision Gate-O-Matic 5000. You can purchase this at liftdarkstudios.com. Thank you guys for watching. Support those that support us. I think without ARC3, we really wouldn't have met the Fronius team and like gotten to do these demos and stuff. So definitely check out ARC3 because they've been awesome for us, and they're just great people who want to make sure that welders like Hunter and I and Troy have all the info and access that we need to be good at our job. So heck yeah to ARC3, heck yeah to Fronius. Like and subscribe, follow Fronius, follow us. We will see you on the next one. Thank you so much. Bye.